The ocean inside the earth, hidden waters beneath our feet. Part 1. Introduction. A hidden world beneath us. Good evening, dear listener. As you settle into your comfortable space, let the weight of the day melt away. Close your eyes and imagine yourself drifting downward, sinking slowly through the earth, like a gentle raindrop absorbed into the soil. This evening, we embark on an extraordinary journey, not into the heavens above, but deep into the very planet beneath our feet. Beneath the surface of our world lies a hidden, mysterious realm, an ocean unlike any we have ever seen. Not the rolling waves of the Atlantic or the deep trenches of the Pacific, but something far more enigmatic. Scientists believe that deep within the Earth's crust and mantle, vast reservoirs of water exist, locked away in crystalline structures, hidden in caverns, and perhaps even forming underground seas we have yet to explore. Take a deep breath. Let your mind open to the possibilities as we venture into the unseen, the unknown. This is not science fiction, but a reality we are only beginning to understand. Could there be entire oceans below us? Could life exist there, cut off from the surface for millions of years? What secrets does our own planet still hold? As you relax into this journey, picture yourself walking along an ancient landscape where water seeps from the earth like a secret whisper. This is the first step into a world long hidden, a world waiting to be uncovered. Part 2. The Earth's Mantle, a reservoir of hidden waters. As we continue our journey into the depths of our planet, let's delve into the Earth's mantle, a vast layer of rock extending from the crust to the outer core. This region, though seemingly solid, harbors secrets that challenge our understanding of Earth's composition. Imagine descending through the Earth's crust, a thin veneer compared to the layers beneath, and entering the mantle. Here temperatures soar and pressures intensify, transforming familiar minerals into new forms. Among these, a remarkable mineral known as ringwoodite emerges. This high-pressure phase of olivine, a common mineral in the upper mantle, has a unique ability. It can trap water within its crystalline structure. Studies have shown that ringwoodite can contain up to 2.6% water by weight, suggesting that the mantle's transition zone, located between 410 and 660 kilometers deep, could potentially hold an amount of water comparable to, or even exceeding, all of Earth's surface oceans combined. This discovery reshapes our perception of the deep Earth. The notion of vast water reservoirs beneath our feet, locked within minerals like ringwoodite, invites us to reconsider the dynamic processes that have shaped our planet over billions of years. As you visualize this subterranean world, picture a landscape where minerals glisten with trapped water and vast expanses of rock harbor secrets of ancient oceans. This hidden realm, though out of sight, plays a crucial role in Earth's geology and the life it sustains. Part 3. Subterranean rivers and lakes. Nature's hidden waterways. As we journey deeper into the Earth's crust, we encounter a network of hidden waterways, subterranean rivers and lakes that flow silently beneath our feet. These underground bodies of water, often nestled within vast cave systems, have sculpted some of the most mesmerizing landscapes on our planet. Imagine walking through a dense forest, the sunlight filtering through the canopy above. Suddenly, you come across a sinkhole, a gateway to the underworld. As you descend, the air cools, and the sounds of the surface fade away, replaced by the gentle echo of dripping water. Before you lies a subterranean river, its clear waters winding through ancient rock formations, illuminated by the faint glow of bioluminescent organisms. One such marvel is the Cave of the Lakes in Greece. This cavernous wonder boasts a series of cascading lakes, each at a different level, connected by natural stone bridges and tunnels. During the wet season, melting snow transforms the cave into a flowing river with waterfalls, while in the dry season, the water recedes, revealing 13 serene lakes. The cave's unique structure and beauty have captivated explorers and visitors alike. In Iran, the Chara Daria presents another intriguing example. This natural well and underground lake, located in the deserts of Kerman province, is shrouded in mystery and local legends. With a diameter ranging from 20 to 60 meters and a depth of 93 meters, Chara Daria has been a source of fascination and folklore, with tales of explorers venturing into its depths, never to return. These subterranean waterways are not just geological curiosities, they play crucial roles in the hydrology of karst landscapes. In regions characterized by soluble rock, such as limestone or dolomite, surface water can seep into the ground, carving out extensive cave systems over millennia. This process gives rise to underground rivers and lakes, which can re-emerge at the surface as springs, contributing to the formation of unique ecosystems. As you relax and let your mind wander through these hidden realms, envision the tranquil beauty of these underground landscapes. Picture the crystal-clear waters reflecting intricate stalactites hanging from cavern ceilings, the gentle sound of water echoing through the chambers, and the sense of timelessness that pervades these secluded worlds. Part 4. The Deep Biosphere. Life in the Earth's Hidden Depths. As we continue our descent into the Earth's interior, we enter a realm known as the deep biosphere, a vast hidden ecosystem teeming with life, far removed from the sunlight and conditions we typically associate with living organisms. Microbial life in the deep. In these subterranean environments, microorganisms such as bacteria and archaea thrive, adapting to extreme conditions of high pressure, limited nutrients, and varying temperatures. Remarkably, the deep biosphere is estimated to contain about 70% of the Earth's bacteria and archaea, accounting for up to 23 billion tons of carbon. Multicellular organisms in the depths beyond microorganisms. Multicellular life has also been discovered in these depths. For instance, the nematode Halicephalobus mephisto was found at depths of up to 3.6 kilometers in South African gold mines. This tiny worm thrives in environments with high temperatures and low oxygen levels, showcasing the resilience of life. Subglacial lakes. Isolated ecosystems hidden beneath Antarctica's ice sheets lies Lake Vostok, one of the largest subglacial lakes in the world. Isolated for millions of years, this lake presents unique conditions that may harbor life forms adapted to cold, high pressure, and oxygen-rich environments. The exploration of Lake Vostok offers insights into how life might exist in extreme conditions, both on Earth and potentially on other celestial bodies. The implications for extraterrestrial life. The discovery of life in such extreme and isolated environments on Earth expands our understanding of the potential for life elsewhere in the universe. If organisms can thrive miles beneath the Earth's surface or in subglacial lakes, It raises the possibility that life could exist in similar habitats on other planets or moons, such as Mars or Europa. Say with summary, as you relax and envision these hidden realms, imagine the resilience and adaptability of life, flourishing in darkness and isolation, far beneath our feet. This journey into the deep biosphere reminds us of the vastness and mystery that still lies within our own planet. Part 5. The Deep Water Cycle. Earth's Hidden Hydrological System. As we continue our exploration into the mysteries beneath our feet, we encounter the concept of the deep water cycle, a hidden hydrological system that operates far below the Earth's surface, influencing geological processes and the planet's overall water distribution. Understanding the deep water cycle, unlike the familiar surface water cycle, which involves processes like evaporation, precipitation, and river flow, the deep water cycle pertains to the movement of water within the Earth's mantle and crust. This cycle involves the subduction of water-bearing minerals into the mantle and the subsequent release of water through volcanic activity. Subduction and water transport at tectonic plate boundaries, oceanic plates, saturated with seawater, descend into the mantle in a process known as subduction. As these plates plunge deeper, increasing pressure and temperature cause hydrous minerals to release their water content. This liberated water can induce melting in the overlying mantle wedge, leading to volcanic activity at the surface. Water storage in the mantle. The Earth's mantle isn't a dry, barren layer. It contains minerals capable of storing significant amounts of water, notably minerals like wadsleyite and ringwoodite, found in the mantle's transition zone between 410 and 660 kilometers deep, can incorporate water into their crystal structures. This suggests that the mantle could hold an amount of water comparable to, or even exceeding, all of Earth's surface oceans combined. Seaworm implications of the deep water cycle. The deep water cycle plays a crucial role in regulating Earth's geological and environmental processes. This is volcanism. Water released from subducted slabs lowers the melting point of mantle rocks, facilitating magma formation and volcanic eruptions. This is tectonics. Water within the mantle affects the viscosity of rocks, influencing the movement of tectonic plates and the occurrence of earthquakes. This is surface water regulation. Over geological timescales, the deep water cycle contributes to the regulation of sea levels and the distribution of water between Earth's interior and surface. As you relax and contemplate this hidden cycle, envision the vast, slow-moving processes that transport water deep into the earth and back to the surface. This continuous exchange reminds us of the intricate and dynamic systems that sustain our planet. Part 6. Myths and Legends of Subterranean Realms. As we journey deeper into the Earth's mysteries, we encounter a rich tapestry of myths and legends from various cultures that speak of hidden worlds beneath our feet. These stories, passed down through generations, reflect humanity's fascination with what lies beneath the surface. The Sumerian Abzu. In ancient Sumerian mythology, the Abzu was considered the primeval sea beneath the earth. It was believed to be a vast freshwater ocean, the source of all life and fertility. The god Enki, deity of wisdom and water, resided in the Abzu, overseeing the subterranean waters that nourished the land. This concept highlights the Sumerians' reverence for the life-giving properties of hidden waters beneath the earth. The Celtic otherworld, Celtic mythology, speaks of the otherworld, a realm existing parallel to our own, accessible through caves, mounds, or beneath bodies of water. This enchanted land was believed to be the dwelling place of deities, spirits, and ancestors. Tales tell of heroes venturing into these subterranean realms, encountering wonders and challenges, and returning with profound knowledge or treasures. The legend of Agartha. The myth of Agartha describes a vast underground kingdom inhabited by an advanced civilization. According to legend, this hidden world is connected to the surface by secret tunnels and entrances scattered across the globe. Agartha is often depicted as a utopian society, possessing advanced knowledge and technology, and living in harmony with natural laws. The Hollow Earth Theory. The Hollow Earth Theory proposes that the planet is entirely hollow or contains substantial interior spaces. This idea has been featured in various myths and fictional works, suggesting the existence of entire civilizations residing within the Earth. While lacking scientific evidence, the concept continues to intrigue and inspire stories of subterranean worlds. The sunken kingdom of Cantra Gwael Weld. Welsh folklore tells of Cantra Gwael Weld, a fertile land stretching across what is now Cardigan Bay. According to legend, this lowland kingdom was protected from the sea by a series of dikes and sluice gates. One night, due to negligence or a great storm, the defenses failed, and the sea engulfed the land, submerging it forever. Some believe that remnants of this sunken kingdom can still be seen along the Welsh coast. Implications of these legends, these myths and legends, while varied in origin and narrative, share a common theme: the existence of hidden realms beneath the Earth's surface. They reflect humanity's enduring curiosity and the allure of the unknown. While modern science has yet to uncover evidence supporting these subterranean worlds, the stories continue to captivate our imagination. As you relax and let your mind wander through these tales, envision the rich cultural landscapes that gave birth to these legends. Imagine the storytellers of old, gathered around fires, sharing tales of hidden worlds beneath our feet, inspiring wonder and contemplation about the mysteries that lie below. Part 7. Hydrothermal Vents. Earth's Underwater Hot Springs. As we continue our exploration of the hidden waters beneath our feet, we turn our attention to the ocean floor, where hydrothermal vents, often referred to as Earth's underwater hot springs, spew mineral-rich, superheated water into the cold depths of the sea. These vents are not only geological marvels, but also cradles of unique ecosystems that thrive in extreme conditions. Formation of hydrothermal vents. Hydrothermal vents are typically found along mid-ocean ridges where tectonic plates are diverging, allowing magma to rise and create new oceanic crust. Seawater seeps into the Earth's crust through fissures, becomes superheated by underlying magma, and then rises back to the ocean floor, carrying dissolved minerals. Upon contact with the cold seawater, these minerals precipitate, forming chimney-like structures. Types of hydrothermal vents. Black smokers. These vents emit dark, mineral-laden fluids rich in sulfides, which precipitate upon contact with seawater, creating towering chimneys that can reach heights of up to 60 meters. White smokers. These vents release lighter-hued minerals, such as those containing barium, calcium, and silicon. They tend to have lower temperature plumes and form smaller chimneys compared to black smokers. Unique ecosystems. Despite the absence of sunlight, hydrothermal vents support diverse ecosystems. Microorganisms utilize chemosynthesis, deriving energy from chemicals in the vent fluids, forming the base of a food chain that includes giant tube worms. These organisms can reach lengths of up to 3 meters and harbor symbiotic bacteria that provide nutrients. Vent crabs and shrimp. Species adapted to the extreme conditions around vents, feeding on microorganisms and detritus. Various mollusks, including unique species of snails and clams that have adapted to the vent environment. Recent discoveries explorations have revealed that life associated with hydrothermal vents extends into the ocean's crust. For instance, in October 2024, scientists discovered giant tube worms and other marine invertebrates living within cavities in the Earth's crust near hydrothermal vents, expanding our understanding of these unique ecosystems. Implications for life beyond Earth. The discovery of life thriving in such extreme environments on Earth has profound implications for the possibility of life elsewhere in the universe. It suggests that if similar conditions exist on other celestial bodies, such as Jupiter's moon Europa or Saturn's moon Enceladus, life could potentially exist there as well. As you relax and envision these underwater realms, imagine the towering chimneys of hydrothermal vents, the shimmering heat rising from the ocean floor, and the vibrant communities of organisms that call these extreme environments home. This hidden world beneath the waves is a testament to life's resilience and adaptability. Part 8. Deep Sea Brine Pools. Underwater lakes of mystery. As we continue our journey into the hidden waters beneath our feet, we encounter the enigmatic deep-sea brine pools, often referred to as underwater lakes. These unique formations found on the ocean floor are characterized by their high salinity and distinct separation from surrounding seawater, creating environments both mesmerizing and perilous. Formation and characteristics. Brine pools are depressions on the seafloor filled with highly saline water, often 3 to 8 times saltier than typical seawater. This extreme salinity prevents mixing with the surrounding ocean, resulting in a clear, visible boundary that resembles a lake within the sea. The high density of the brine creates a distinct surface and shoreline, giving the illusion of an underwater lake. The notable brine pools. Orca Basin. Located in the Gulf of Mexico, the Orca Basin is a mid-slope, silled mini-basin containing a large brine pool of anoxic salt brine. Covering approximately 123 square kilometers, and reaching depths of up to 220 meters, it is derived from the dissolution of underlying Jurassic Age Luan salt. Red Sea brine pools. The Red Sea hosts several brine pools, including the Atlantis the Deep, Discovery Deep, and the Kebrit Deep. These pools are known for their extreme conditions, with temperatures ranging from 2.0 degrees Celsius to 75 degrees Celsius, and support unique microbial communities adapted to such harsh environments. Life in extreme conditions. Despite their inhospitable nature, brine pools harbor specialized life forms, the microbial extremophiles. Certain bacteria and archaea thrive in the anoxic, hypersaline conditions of brine pools, utilizing chemosynthesis to convert methane and hydrogen sulfide into energy. To symbiotic relationships. Some larger organisms, such as mussels, have formed symbiotic relationships with these microbes, allowing them to survive at the edges of brine pools where conditions are less extreme. To symbioasant discoveries. In February 2025, scientists exploring the Gulf of Aqaba, a region associated with biblical narratives, discovered mysterious death pools 4,000 feet below the surface. These brine pools are up to 10 times saltier than normal seawater and lack oxygen, creating lethal conditions for most marine life. Larger predators were observed lurking near the edges, preying on organisms that ventured too close and became stunned or killed by the toxic environment. The scientific significance studying brine pools offers valuable insights. The symptoms of life, the extreme conditions of brine pools, resemble those of early Earth, providing clues about how life might have originated in anoxic environments. Tessemated extraterrestrial analogues. These unique ecosystems serve as analogues for potential life-supporting environments on other celestial bodies, aiding in the search for extraterrestrial life. Tessematu geological records. The undisturbed sediments within brine pools preserve historical climate data, allowing scientists to reconstruct past environmental conditions and better understand Earth's climatic history. Tessemati. As you relax and envision these underwater realms, imagine the serene yet eerie landscapes of brine pools, still, dense waters nestled within the ocean's depths, harboring life forms that defy conventional understanding. These hidden lakes beneath the sea remind us of the vast mysteries our planet still holds. Part 9. Subterranean aquifers. Earth's hidden reservoirs. As we delve deeper into the mysteries beneath our feet, we encounter the vast and vital world of subterranean aquifers, natural underground reservoirs that store and transmit groundwater. These hidden water sources play a crucial role in sustaining ecosystems, supporting agriculture, and providing drinking water to communities worldwide. Understanding aquifers. An aquifer is a body of permeable rock or sediment that can contain or transmit groundwater. Aquifers are typically composed of materials like sand, gravel, sandstone, or fractured rock, which have sufficient porosity and permeability to allow water to flow through them. They are replenished or recharged by precipitation infiltrating the ground and percolating down to the water table. The top of the saturated zone in an aquifer is known as the water table. Two types of aquifers: unconfined aquifers. These are aquifers where water seeps from the ground surface directly above the aquifer. They are bounded below by impermeable layers but have no confining layer above, making them more susceptible to contamination from surface activities. Sewer confined aquifers, also known as artesian aquifers. These are sandwiched between two impermeable layers of rock or clay. The water in confined aquifers is under pressure, which can cause it to rise above the top of the aquifer when tapped by a well. Sewer significance of aquifers. Aquifers are essential for several reasons. Sewer water supply. They provide approximately 30% of all readily available fresh water globally, serving as a primary source of drinking water for billions of people. Sewer agriculture. Groundwater from aquifers is extensively used for irrigation, supporting food production worldwide. Sewer ecosystems. Aquifers sustain wetlands, rivers and lakes, maintaining ecological balance and supporting biodiversity. Sewer challenges facing aquifers. Despite their importance, aquifers face several challenges: overexploitation. Excessive groundwater extraction can lead to declining water tables, reduced water availability, and land subsidence. Sewer pollution. Contaminants from industrial activities, agriculture, such as pesticides and fertilizers, and improper waste disposal can infiltrate aquifers, degrading water quality. Sewer climate change. Altered precipitation patterns and increased drought frequency can affect aquifer recharge rates, impacting their sustainability. Sewer pollution. Notable aquifers around the world. Ogallala Aquifer, stretching beneath 8 states in the United States. The Ogallala Aquifer is one of the largest freshwater aquifers globally. It supports about 30% of the U.S. irrigation needs, but has been experiencing significant depletion due to extensive agricultural use. The Nubian sandstone aquifer system, located beneath parts of Libya, Egypt, Sudan, and Chad. This fossil aquifer contains ancient water that infiltrated the ground thousands of years ago. Its non-renewable nature necessitates careful management to prevent over-extraction. Sewer Great Artesian Basin, covering a vast area in Australia. This is one of the largest and deepest artesian basins globally, providing a crucial water source for arid and semi-arid regions. Sewer sustainable management of aquifers. To ensure the longevity and health of aquifers, sustainable management practices are essential. Monitoring and regulation. Implementing policies to control groundwater extraction and prevent overuse. Sewer pollution prevention. Establishing guidelines to reduce the introduction of contaminants into the groundwater system. Sewer recharge enhancement. Promoting land use practices that enhance natural recharge, such as preserving wetlands and implementing managed aquifer recharge projects. Sewer tool lets you relax and envision these hidden reservoirs beneath our feet. Consider the intricate balance they maintain in our planet's water cycle. These subterranean aquifers, though unseen, are lifelines that sustain human societies and natural ecosystems alike. Part 10. The Earth's Mantle, a reservoir of hidden waters. As we conclude our exploration of the hidden waters beneath our feet, we turn our attention to the Earth's mantle, a vast layer of rock extending from the crust to the outer core. This region, though seemingly solid, harbors secrets that challenge our understanding of Earth's composition. Sewer water in the mantle. The Earth's mantle isn't a dry, barren layer. It contains minerals capable of storing significant amounts of water. Notably, minerals like wadsleyite and ringwoodite, found in the mantle's transition zone between 410 and 660 kilometers deep, can incorporate water into their crystal structures. This suggests that the mantle could hold an amount of water comparable to, or even exceeding, all of Earth's surface oceans combined. Even implications of mantle water. The presence of water in the mantle has profound implications for our planet. Even tectonic activity. Water influences the melting point of mantle rocks, affecting magma formation and volcanic activity. Even seismic behavior. Hydrated minerals can alter the physical properties of rocks, impacting the transmission of seismic waves and our understanding of Earth's interior structure. Planetary evolution. The deep water cycle plays a crucial role in regulating Earth's geological and environmental processes over geological timescales. As you relax and contemplate this hidden reservoir, envision the vast, slow-moving processes that transport water deep into the earth and back to the surface. This continuous exchange reminds us of the intricate and dynamic systems that sustain our planet.